This is problem number 8 from section 1.4. And the question is, does the collection of vectors v1, v2, v3 span R4? And that's four-dimensional space. Now remember, that means, if it's true, that every vector in R4 can be written as a linear combination of v1, v2, and v3. Is that true? Well, to answer that question, we really have to decide if you choose any vector in R4, and I suppose we could do this. Let b1, b2, b3, b4 be a 4x1 vector in R4, and those b's are just arbitrary constants. So every vector in R4 has that form. Let that be an arbitrary vector in R4. So the question is, do there exist constants, x1, x2, x3, that will make this true? Can we satisfy that equation for an arbitrary collection of b's? Can we find x1, x2, x3 that will satisfy the equation? Okay, well, let me replace those v's with their vectors first. We'll answer that question in a second. And remember, those b's are completely arbitrary, so we should be able to satisfy that equation for any collection of b's if this is true. But notice that that's really equivalent to a system of equations, as we already know. And the augmented matrix for that system looks like this. So we really just have to do what we've done several times already, which is put this thing in reduced echelon form, see if we can come up with a solution. And the only way that it's not going to be solvable is if one of the rows looks like 0, 0, 0, non-zero number. So we just have to look and make sure that that doesn't happen. Okay, so let's go ahead and put it in reduced echelon form. First thing I would do, I suppose, is change that to a +1. Multiply the whole first row by -1. The numbers are kind of nice in this one, which is merciful. Okay, now let's change this to a 0. So I'm just going to multiply the whole first row by -1 and add it to the third row. So multiplying the first one by -1 and adding it to the third, that'll give me a b1 plus b3 right here. All right, and I think the last row is okay the way it is. All right, now let's move on to the second column. We know it has to be 0, 1, 0, 0 to be in reduced echelon form. So I would multiply the second row by -1. All right, so next thing is to make this a 0. So I'm just going to add row 2 to row 3 to make it a 0. The other rows I'm going to leave alone. So row 2 plus row 3. And it looks like the last row is okay the way it is for right now. Okay. Well, you can almost stop right there because take a look at this third row. I mean, it's not really in reduced echelon form yet, but we've already come across a problem. Because remember what I said before, these systems of equations only don't have a solution. If you can find a row with all zeros, but maybe the last element not being a zero. And we don't know what B2, B1, and B3 are, but I could always choose those numbers to make that non-zero. So this row right here implies that there's no solution in general. Now, it might have a solution for a specific choice of B2, B1, and B3, but in general, there is no solution to the system. So that means that that V1, V2, and V3 do not span R4.